regardless of where or how life originated on Earth, we do know what happened after life originated on Earth. So the first organisms existed during the Archean. Remember, this is the second eon. It's after the Hadean. Right? And during this time, life was prokaryotes, meaning single-celled. They do have DNA. It's not packaged in a nucleus, though, and they reproduce asexually by cell division. Okay. Prokaryotes are in the domains of archaea and bacteria. Okay. So they still exist today. Now, this fossilized bacteria has been found in rocks dated to about 3.5 billion years ago. So we actually have found fossils of these tiny, tiny prokaryotic organisms. And some geochemical evidence indicates that prokaryotic organisms may have been around even before then, 3.8 billion years ago, but we actually have the fossilized bacteria 3.5 billion years ago. Now, far more abundant during the Archean than the early traces of life are stromatolites. Okay, now, stromatolites, they existed during the Archean, the late Archean, right? But they're really cool. They're not these single-celled organisms like the prokaryotes. Instead, they are large sedimentary structures that are formed indirectly as the response to the liberation of carbon dioxide by mat-like colonies of photosynthetic cyanobacteria. What this means is that these huge, not quite huge, these larger, right? It's about the size of a stool. I could sit on one of these things. These larger masses were created by thousands of tiny little bacteria. Right? Stromatolites do still exist today. So you can actually go touch one of these. I've seen some in the Caribbean. Super cool. They're just like little mounds that live in shallow ocean water. Now, stromatolites develop when really fine particles that are floating around in the ocean water, like calcium carbonate, settle onto the sticky surfaces of cyanobacterial mats. So cyanobacteria, they form as a mat. They're slimy, they're sticky, and so the material in the shallow ocean water sticks to them. These bacteria colonies then grow up through the newly deposited layer of sediment, and then more sediment deposits on top of that. And then those bacteria grow up through that new layer of sediment, and then more sediment is deposited on that, such that layers of sediment build up and up and up and up and up because of the presence of these cyanobacteria. Okay. So here's an image of a fossilized stromatolite. You can see that, right, it grew upwards as each new layer of sediment was deposited on it. The bacteria grew upwards, causing the entire stromatolite to grow up and out. So in Earth's long history, if it were a play, the Archean was just the first act, right? It set the stage. Now, during the Archean, our planet aggregated from a solar nebula. The Earth's moon formed from a giant impact. Earth developed the internal zones of the core, mantle, and crust. The Earth also developed a magnetic field. Continents were formed. Oceans were formed, the atmosphere was formed, and during the Archean, the first life on Earth appeared, right? So we're setting the stage for what life is today and what the Earth is today in the Archean.